Thank you, everybody. Hello, Athens. How is everyone? How was lunch? Was it good? Are you getting that carb coma now? I think I had too much of the bread. Did anybody else have too much? Anybody fall asleep in the last session? Anybody already asleep in this session? So thanks for coming along to my talk. I know there's a couple of options today. Hopefully you'll find at the end that you made the right choice. If at any point during the talk you're thinking, this isn't what I expected, I will not be offended if you leave. It's more important to me that you're where you need to be during this event than in this room. But with that said, I hope you're entertained and informed by what I'm about to go through. My name is Ben, as I mentioned. I've been a software engineer for over 25 years, been doing solutions architecture and that kind of stuff for over 15. And as in my intro, which I think I probably need to cut down, that was a mammoth intro you just gave me there, thank you. It's not until you stand on stage and somebody's introducing you realize you probably need to cut that down a little. My biggest passions and focus are in security, privacy, all of those kind of things. So that's why I want to talk to you today about access control, in particular fine-grained access control and relationship-based access control. But we're going to go through some of the fundamentals first to get us to why ReBAC is good and also why maybe you shouldn't choose to use it. More importantly, though, I need to know from all of you, how many of you are dog people? Probably about 20%. This doesn't make me very happy. How many of you are cat people? 15%. More dog people, this is good. I'm also a cat person, I'm a bit of both, but we've got a few dogs in this talk, so I just wanted to make sure that you're all on board with having a couple of canine friends come along and help us with the examples. So, let's have a look at Access Control 101 first. Let's have a look at what access control is, where we've come from, before we then start looking at relationship-based access control. So is anybody here familiar? Actually, before I go into that, let's have a look at the three things that we look at when we talk about any kind of access control. We have entities. These are the things that want to access something. Then we've got the resources. These are the things that we want to access. And then in the middle, we've got a set of rules which define whether or not the entities get access to the resources. Fairly straightforward. The most simple version of that is role-based access control. Who's familiar with role-based access control? Most of you, that's great. So just as a refresher, in case you need it, role-based access control has, this is Shadow, this is my dog, Shadow on the left here. These are all generated by DALL-E about 2 years ago, so excuse the high-fidelity dog imagery here. But this is Shadow on the left, and he wants access to the bone. And with role-based access control, we can give him one or more of a few roles. So we might have an admin, a manager, an employee, and a guest. These are roles that you can put on to an entity within your system. And in this case, we're going to give him the employee role. I don't quite trust him as a manager or an admin. We could give him multiple roles. I don't trust him yet. So I'm just going to make him an employee. And then we can look at what the rules are as to whether or not he's allowed to get access to the bone. So the door itself, the rules, on there we can see you can have to be an admin, a manager, or an employee. Guests cannot have the bone. Sorry, guests. You need to be at least employed. In our case, or in Shadow's case, he's lucky. He is an employee, therefore he gets access. So door opens, he gets access to the bone. Very simple, probably the second most rudimentary access control system out there. The simplest being, are you logged in? You'll often find, for example, with your home internet router, that if you are not logged in, you don't get access. If you are, you do. But there is no more access control beyond that. Whereas in role-based access control, you can put a little bit of a definition of who gets access to what by virtue of which role they're in, which team they're in. But it's a single thing that you're attributing to that entity. So along comes attribute-based access control. Familiar with attribute-based access control? Just under half of you, cool. So we're getting into how to extend access control, how to make it work for us more than just role-based access control. Role-based access control, when you think about it, is attribute-based access control. There's just one attribute, the role. In attribute-based access control, we can have multiple attributes that define whether or not a resource will get access to the entity that they're trying to access in whatever way. So in this case, we might have attributes like, this is Min, by the way, this is Shadow's best friend. They are both real animals. Min is actually his best friend. So we've got a couple of attributes here for a dog. A service dog, a good boy, loyal, and fierce. Anybody think that Min might be fierce? She looks fierce. She can be fierce. She's bitten my hand a few times. I can tell you one thing. She's definitely not a service dog. Shadow's trained as a service dog. She will never be trained as a service dog. She's a Siberian Husky. She is so independently, she's almost like a cat. She's like, no, I will not do what you tell me to do. And yes, I will have that treat. Thank you very much. So she's definitely not a service dog. I think we can probably call her loyal, though. She'll almost always come back when you call her. But if you're hurt, she'll come and lick you. So I think there's a little bit of a loyalty in that. So we can say here, if you're a good boy, or if you're loyal, you get access to the bone. Does anybody have any problems with this rule? I've had people say before, but what about service dogs? Don't they deserve a bone? Who here thinks that the service dogs should get a bone? You're wrong. If there's one thing, no, this is not the key of this talk, but service dogs are working animals. They don't get bones. They get bones when they're no longer a service animal, when they're no longer on duty, in which case they're always a good boy and definitely loyal. So they will get the bone when they finish their day's work. But while they're working, service dogs will not get access to the bone. But in this case, we're also going to put in an extra criteria. We're going to say it has to be between 9 in the morning and 9 in the evening. Who here has a dog? Who here lets the dog sleep in their bedroom? Who here would like to hear the dog in their bedroom chewing on a bone at 3 a.m.? Exactly. So we have two here. We've got attributes based on a role in this case. The role is, in this case, is loyal. But we also have an attribute of time. What is the current time? So we can even change the rules depending on the time of day. In this case, it is 3 o'clock in the morning. Unfortunately, that means this is no longer satisfied. The rule is no longer satisfied, so Min does not get the bone. But as you can see here, there are multiple other kinds of attributes that we could use. We've got things like weather. Maybe you only want access to the rooftop when it's not raining. We've got things like identity. Do you actually have an identity badge that you can swipe into a building with? Do you have identity in terms of your fingerprints, like who are you biometrically? We can also do things based on location, both physically in the world or which computer network you're on. So lots of different attributes you can add and layer into attribute-based access control in order to give you more fine level, not fully fine, because we're going to come to that, but more fine level control over who gets access to the resources. Does that make sense? All right, let's move on to relationship-based access control. And this is fairly new. I mean, there's products and companies out here providing this already for the past 2 to 3 years. The product itself is based on a project called Zanzibar by Google, which came out, I believe, is about 2014. And if you think about the complexity of providing access to documents in Drive based on which department you're in, which folder the document is in, various other things, it's no longer about attributes, it's about relationships. How are you related to the entity that you're trying to have an action on? So in this case, we're looking at relationship-based access control, and we will have a look how that works. So we've got another friend here. This is Wilbur. Wilbur is Shadow and Min's best friend. He also actually exists, and he also is a service dog. But in this case, his service dog status is not going to come into question because we're just basically going to look at the relationship that Wilbur has with the world around him. So we know that Wilbur, oh yes, it might look like a cat. It's not. So we know that Wilbur has an owner who's a mad scientist. Now, Wilbur's owner is actually a mad scientist, but looks a lot better than this. She is, though, friends with a farmer. I'm pretty sure I haven't checked with her. But we're going to go with the fact that she's friends with a farmer, and that farmer has sheep. And for the vegetarians and vegans in the room, I apologize in advance. Sheep have bones, and dogs like bones. It's just the way the world works. So what we want to work out is, does Wilbur have access to the bone? And in this case, the rules are quite verbose. So let's just zoom in on that slightly. In this case, what we're doing is we're assigning the ability to do an action or perform an action on the resource that we want to perform the action on, not a question on the entity that's performing it. So in role-based access control and attribute access control, you look at the entity that's trying to do something, and you say, do you have access? In relationship-based access control, there's a mouthful, you look at the entity that you're trying to actually access the resource. And you look at what rules have to be met in order to access it. And interestingly, because of that switch, in relationship-based access control, we don't really talk about resources anymore. Everything is now an entity. So you have entities, relationships between them. You have inferred relationships. In this case, we can infer a connection between the bone and the mad scientist because of the entities in between it. So the rule for the bone is there is an action that you can call called eat. And the eat action is permitted if the person or the entity making the request is the animal's owner, or it's the animal's owner's friends, or it's the animal's owner's friend's pet. I think for logical reason, I didn't allow the animal to eat its own bone. I think we can all agree that's a good thing. But yes, all around there, as long as there's a relationship, that ability to eat the bone exists. So, let's follow the path along. We've got the bone on the right-hand side there. The bone belongs to the bottom right-hand sheep. The sheep belongs to the owner. The owner's friends with the mad scientist, and the dog that looks like a cat is owned by the mad scientist. So we've got a green line all the way along there, so we can see that that third condition there is the animal's owner's pet's friend's pet is satisfied, therefore the door opens. So whereas before, in attribute or role-based access control, if we change one of the attributes or the role, we were changing something on the entity that was making the request. In this case, let's break the friendship between the farmer and the mad scientist. If we break that friendship, suddenly friend is no longer a relationship, therefore that third line is now not satisfied. So by breaking that relationship up there, nothing to do with the dog, nothing to do with the bone, but because we broke that relationship up there, now the dog can no longer access the bone. It's a really powerful way of looking at authorization, but as you can also imagine, it's very intensive to try and work out all these paths of whether or not somebody is allowed to do something to something else. So one of the first things you'll probably gather is that while this is powerful, there's also an overhead to consider. So when you are looking at access control within your systems, if you're thinking about relationship-based access control, also consider the performance impact that that's going to have. It's going to require more processing time, but if that's what you need, that processing time is worth the extra functionality and the fine-grained access control that you get from it. All right, so let's have a look at how ReBAC works under the hood, and this is where we're going to dive really deep into a little bit of techie stuff. We're going to be looking at tables and relationships and trying to follow stuff through in our heads. Hopefully I've made it as easy to follow along as possible. But then after this, don't worry, this is like the pit of despair in this part of the talk. Hopefully informational, but also might hurt your head a bit. But we will come out the other side, we'll skyrocket back up, we'll go through some use cases, and then we'll have a look at a demo, okay? Great. So, ReBAC under the hood. If anybody here is familiar with entity attribute value tables, the way that you can model multiple tables within a multiple object, what's the word I'm looking for? Multiple entities within, like, for example, a content management system. This is similar to the way that works. So if you're familiar with that already, that might help you understand this. I won't go into depth on how that works, but if you are interested, come and chat with me afterwards. But let's have a look at how we're going to model these under the hood. So we've got 3 entities, and you'll notice none of this is about content. This is all about permissions. So even though the entities are of different types, we don't need different tables for different types of entity. All we know is there is an entity, and it has a relationship to another entity. So we've got Robin. Robin is of an entity type user. We've got Acme Co, which is an organization. And then we've got ReBAC for the win, which is a blog post that was highly successful. I don't know. So then we need to define relationships between these, and we've got a subject entity ID and object entity ID. Remember I mentioned that everything's just an entity with a relationship? If you think of a relationship as that arrow, it's between a subject and an object. So the subject that we're talking about in the first place, if we wanted to assign something to Robin, for example, would be entity ID 1 would go into subject entity ID, because that's what we're talking about. We're talking about Robin. So let's do that. Let's create a relationship between Robin, entity ID 1, and the article, entity ID 3. And that relationship is going to be of type owner. Now, owner is just a label. We could call that whatever we want. This is not permissions yet. This is just when you create something, you say, I want to create a relationship of type owner. It's insignificant. It only helps us as humans understand what that relationship is. But we now know that Robin is the owner of the article. We can also say that Robin is a member of the Acme Co organization. So Robin is an employee or a contractor or in some way related to this as a member. Then we're going to add a second user, Morgan. Morgan is also a member of the Acme organization. So we now have Acme organization with 2 members, and we've got the article, which is owned by Robin. So finally, what we want to do is we want to associate, and this is where we get into a little bit of the complexities and the strength of relationship-based access control, is we're starting to create relationships between relationships. So down here, we're saying the subject organization is related to the article as a viewer. But when you think about it, an organization can't view an article. That's like saying Devoxx can read my email. Like, that just doesn't make sense. Somebody at Devoxx might be able to read my email, and if you can, please tell me how you got in. But we have an entity relation on the right there. So what we're doing here is we're actually extending this. We're saying, if you are a member of the organization, then you are also a viewer of the article. And again, at the moment, this is all labels, not permissions. This is just helping us understand how they are connected together. So let's have a look at how we would, I just highlighted a couple of these to describe exactly what I was just saying. If you're a member of the organization, then you have access to read the article. So let's have a look at the permissions table. We're now going to link these relationships together and give us some kind of permissions based on standard permission types we understand that we can then look up. So the first permission we want to add is a read permission to relationship ID 1. If we remember, relationship ID 1 is that the article is owned by Robin. That ownership, that owner label, again, doesn't mean anything, but there is now a permission assigned to that relationship saying, if this relationship exists, then you can read the article. Let's also add another one for write, because he's the owner. Now we're going to add another one. We're going to add a read for relationship ID 4. That's the bottom one here. Now remember, relationship ID 4 was the one that said members of an organization have access. So members of the organization Acme Co. have read access. But note at the moment that entity ID 4 hasn't really shown up in that permission table. Morgan has no implicit permissions, but Morgan has an implied one through that connection with the organization. So let's now look at how we would then query the ReBAC model. So let's say, for example, we want to find all of the users who could write to the article. So we highlight all the entries in the relationship table here that are related to the write permission type. Now remember, there could be multiple articles. Multiple articles could have write permissions. So we highlight all of those, then we highlight all the ones that are the article that we're talking about, and we can see down here that the last row there, only one of them matches, so that one is not satisfied. But this top one here is satisfied. We can see there's a write permission for object entity ID 3. So from here, we can now follow that through and say, well, subject entity ID is 1, therefore Robin is the person who can write to the article. So now if you imagine yourself in an editor environment in your application, you're trying to work out, should I show the save button? That's the kind of lookup you could do there. Fairly straightforward. Let's have a slightly more complicated one. Let's say you're rendering the article and you want to work out whether you should even render it in the first place for the person who's currently logged in. So let's have a look at who has read access to the article. So in this case, we're going to highlight anything that is a read permission. So we've got relationship ID 1 and 4, so we'll highlight those over here. So potentially those are now in. And then we're going to highlight anything that's the article in question. So we'll highlight those in the relationship table. So now you can see that both of those rows are satisfied. Now we already know that the first one here means that Robin can access it. We worked that one out last time. So let's follow the next one through. We can see that subject entity ID 2 is able to read the article. But we can also see that there's a member relationship on there. So we know by looking at this that this subject is not actually a user. It's some other system, some other entity in the system that is then going to relate eventually to a user or some kind of entity that can read. Like an API backend, for example, can read, even though an organization cannot. So now we need to pull out what that means. So where member in relationship table, we can then highlight that member in the relationship type, because we're trying to find members, yeah? So we look for anything that is a relationship type member, where also the object entity ID is the subject that we had in the previous lookup. Does that make sense? It's a little bit drawn out. So basically, we know that an organization has read access. So now we want to find out who is a member of that organization. So now the organization becomes the subject of our next lookup, and the object, rather, of our next lookup. And now we can see that user 1 is a member of that organization, therefore they can read, but that's Robin, we've got that one already. But also user 4, so now we know that Morgan can also read. So it's convoluted. You can see how systems are going to get slightly overloaded, especially as these graphs get quite big. A very quick one. Let's have a look at what Morgan can do, because we want to go from the other direction. So we find Morgan, we look up Morgan in the table, and we can see there's one relationship. Morgan is related in one way to relationship ID 3, but if we look at the permission table there is no relationship ID 3. So immediately we know that Morgan has no implicit, not implicit, explicit permissions. Next thing we can do, though, is we can see, well, hang on a minute, but this relationship here is a member of another object. So now what we can do is we can look that one up and say, okay, let's find all members, what members of this organization can do, because Morgan is a member of this organization. And because relationship ID 4 exists over here, we can see that Morgan is able to read something. And that something is defined in the object entity ID 3, which is the article. So now we follow that from the opposite end. So as you can see, convoluted, but really powerful in the ways that you can do lookups. And if there's one thing I ask you to do at the end of this talk, is not really worry too much about whether you followed that, but understand that the way this is designed is to give you maximum flexibility to link your entities together through a relationship, and each of those relationships infer explicitly or implicitly a permission. And it's complicated, therefore, if you really want to use it, make sure that your system is actually going to be able to use it. Is not going to be overwhelmed by it. All right, let's come back up. We can breathe for a second. Was that useful to a few of you, just to understand what's going on under the hood? I think sometimes as software engineers, we use tools and we don't necessarily understand exactly how it works. Things like OAuth. We don't really understand how it works necessarily, but we know it does its job. But if we have a little bit of an understanding about it, we can implement it more accurately and with fewer long-term bugs and side effects. So like I say, I don't want you to understand every single detail of what we went through, but have a good understanding of the complexity and the power of it, so that if you choose to use ReBAC, that you're doing it for the right reason. And we'll come back to some more reasons in a second. All right, implementation details. This is what it would actually look like as a developer. So this is like easy, fun part. So let's say we want to allow editing if a user is an admin or an editor. If the editor is allowed to edit, are they allowed to edit this article in particular? If the article is sensitive, then we want to make sure that they are on site, and also that it's during office hours. Seems fairly reasonable. So if we were to do this in some kind of code, we would probably do something like, if the user is an admin or the user is an editor. Also, if the user is an editor, make sure that the list of editors for this document, that they exist in that list. And then if the document is not sensitive, that's fine. We can just return true, as long as the first two are satisfied. If the document is sensitive, however, then we want to extend that and say, make sure the user is on premises, and also make sure that it's during office hours. And we'll make sure the office hours are the office hours of the location, so that if they're roaming around the world, then it's specific to wherever they are at that point in time. Does that make sense? If you came back to that in 4 months' time and somebody said, I need you to change the whether or not somebody can satisfy this rule, it would take you a couple of minutes to get back into it, right? And if there was a complicated change that you then had to apply to a number of different systems, you'd be like, this isn't fun. So let's see if we can make this easier on us as developers. Let's push this into another system. So one of the things I like about ReBAC is that by design, by specification, it's a REST-based system. So you make a request to it and it'll give you a response whether or not access is allowed, or what kind of permissions exist, or various things you can pull out of it, as you saw from the deep dive. The advantage of that is that you implement it in one place, and then all your systems can access it. So let's define, and this is one version of a policy document. Policy specifications are different from system to system. So this is one example. We're going to say we've got a document, and if the owner is of type user, and editor is of type editor on an organization. So we're seeing that familiarity of the table that I came back to before. We've got a member of an organization. Here we've got an editor of an organization. So every document has these two users, or two relationships rather. And then we've got a sensitive document. And sensitive document, we're going to extend the original document, so that also gets the requirement for there to be either an owner or an editor associated with it. So you can only edit it if you are the owner or the editor. But we're going to extend that and say, if you want to edit, you also want to make sure it's within working hours. So this is one of the things I like, is you can actually embed your own business logic within most ReBAC systems. So you can outsource that, because this isn't business logic for your application, this is business logic for permissions. So it makes sense to put that into a permission system. We're also going to check that the document owner is present on premises, and that if they're an editor, that they are present on premises. And we've got the within working hours thing already. So this can now be written, put into your policy manager as part of your access control system. And then if we go back to our code where we had this before, we can replace all of this with that. So now next time somebody comes along and says, I need you to change it so that so these kind of people can edit things as well, you have two choices, depending on the size of your organization and the way your team is structured. You can actually say, not my problem anymore, which would be lovely. Or you can say, sure, I can do that, and then you go over to this system over here and you context switch into, okay, now I'm working on permissions. Whereas over here, I'm working on business logic from the product that we're actually creating, and mixing permissions and business logic doesn't always make sense. It's good to keep a single purpose within the code that you're writing. So we've managed to separate those out now. Also, it means that if you change it in one place, it now affects multiple systems if you have multiple systems that also need to do these lookups. All right, some quick use cases before we go into a demo. Hospital patient records. This is probably one of my favorites. How many people here have been to hospital? I feel, actually, I imagine the number is slightly higher than actually put their hands up, because a lot, not all, but a lot of us were in hospital on day one or day zero of our lives. Are we zero indexed, I think, in our ages? I think so. We have a high need for privacy when it comes to our records. But we also have a very important need for the people who are looking after us in a health environment to know exactly what's going on with us. They need to know our medical history. They need to know what's happening to us now. They need to know what I was prescribed or what I was given the last 5 minutes. But this is very sensitive information. And oftentimes within hospitals, that's all paper-based. And transferring that from one person to another has a very low level of scrutiny. We are moving towards digitization, that's great, but what we need to make sure now is that the access controls for that are up to date as quickly as possible. So what often happens is you might be on a ward and you'll be assigned to a patient and you'll get access to their records, and then once you're taken off that patient or you come back the next day or whatever, that permission will eventually come off because you worked on them at some point and somebody probably manually has to go in, maybe when the patient gets checked out and says, okay, you no longer have access to this. What if we can use relationships to work out if I'm actually working on a patient and I'm on that ward and it's within my working hours, then I have access. That way, as soon as I leave, location is broken, time is probably broken. Even if I'm still assigned to the patient, I no longer have access until I come back into work. If the patient has moved to another ward, nothing changed between me or the patient, but suddenly I don't have access anymore. That's a good thing. Corporate calendar access. If I'm the executive assistant for a super CEO boss, and one day I get reassigned to super CEO VP of something else, by virtue of changing the relationship between me and the person that I'm working with, that relationship is broken. Therefore, I can automatically be revoked from accessing their emails, their calendars, all of these other things. A lot of business systems will already do that. Some of them still require manual intervention to change those. Project management systems. We probably all work with something like Jira or Trello or one of these task management tools. What happens when we drag a ticket into ready for testing? We can still see it. Do we need to? Probably not. We probably never need to see it again unless it comes back to us for rework. So building that relationship modeling in as well means that I remove clutter, but also means that I don't have access to change things after I should no longer have access to change it. Now maybe if testing want to ask me a question, they can tag me, and then suddenly I've got a relationship to it again. So there's all sorts of ways that we can use relationship-based access control to make our lives not only more secure, but also, as users of this information, make it cleaner and easier, harder to make mistakes and easier to gather the information we need. And lastly, the one that we're probably all familiar with is social media platforms. Facebook was one of the pioneers, I believe, in this, in that they had you can view this if you're a friend or a friend of a friend or anybody. So that was starting to look at relationship-based access control. The original implementation probably wasn't ReBAC, but it's certainly a really good example of how ReBAC could be used. So hopefully that's given me a few ideas of where ReBAC is useful in terms of applicability. Again, balance that applicability out with the overheads. Is it actually worth implementing? Maybe in Facebook's case it wasn't. Maybe the overhead of running ReBAC was too high, given the number of requests they get every day. Maybe they would have to do heavy amounts of caching. Maybe they just want to keep with whatever system they've got at the moment. There's no right or wrong. There's just good and maybe better. All right, demo time. We've got about 9 minutes remaining, which is plenty. I found a whole load of different products. If you want to do something like ReBAC, there are a whole load of products here. This is one of the slides you'll want to photograph if you're interested. The one that I'm using is Permify, which is open source. It is very bare bones. It's headless. There's no interface for it. It runs on your machine or whichever machine you want to run it on, but it's very powerful. Some of these, like OpenFGA is by Auth0, Permit.io are a good company that do ReBAC, RBAC, and ABAC products. I haven't used OSO or Auths yet. This guy, Andrew, I'm still trying to meet. If you're in the audience, please come say hi afterwards. Andrew has an open source project on GitHub that is also a ReBAC implementation. So lots of different options for you to choose from, whether you want to go fully enterprise all the way to fully open source, run your own. There's no reason why you can't at least play with this today or tomorrow or Sunday, because you're going to be busy until Saturday, right? So yes, I'm going to look at Permify. Let's switch over to the demo quickly, and we will have a look at how this all works. We switch to mirroring. All right, I will make this bigger. Don't you worry about that. So these 2 links will be up on the final slide, so don't worry about grabbing those just yet. But everything's in GitHub. If you want to download, you should be able to clone this and get it up and running in about 10 minutes and be able to do exactly what I've done here. So I'm starting with Permify. If you go to their documentation, is that big enough for the folks at the back? Yep. If you go to their documentation, you'll see this Docker command, which is what I'm going to be using today. So we'll jump into a terminal, and I'm just going to start this. So as you can see here, normal clicker still work? I think, oh no, it does, there we go. It's very sensitive. So as you can, there we go. As you can see here, we've got an HTTP server and we've got a gRPC server. So HTTP is, in the definition, something you have to provide. gRPC is nice. I think it's great that they offer that too. But this is the only interface you have on Permify. Everything from now on is curl commands or postman clicks or whatever. So let's have a look at how that works. The first thing we want to do is create a new tenant. Let's make this a bit bigger. So we're going to call the tenant's create endpoint, and we're going to say I want to create a new one called dog and bone. I think you can probably guess where this demo is going. I'm going to call it dog and bone. We can either copy that and paste that into the terminal, or, there you go, we can see it's been created. Also, a link on the next slide, so don't worry about grabbing this right now, is I have a Permify dog and bone collection on Postman, so I could come in here and just go create tenant and click. But I've done that already, so I won't. So if you want to try this yourselves, 2 ways for you to have a go. Next thing we're going to do is create the schema. Let's go back to the documentation so we can see what's going on. This one. Let's create the schema. So in this case, we're calling, on the tenant dog and bone, we're calling schema. We're going to pass in raw data and this long schema string. So in most of the examples you see here, I'm able to nicely format it. For some reason, because this goes in as a string, it doesn't like character returns on the command line, and it always breaks. So for our benefit, I've just written down here what I'm posting in as a schema, so we can see what's going on. So we're defining a dog. The dog is related to a person with a relationship of type owner. So a person is an owner of a dog. A person is a friend of another person. A sheep is a sheep of another person. A dog is a dog of a person. Then down here we've got a person is an owner of a sheep. Got a bone is a bone of a sheep. That was weird. I wasn't quite sure what the relationship should be called. I went with bone. And then down at the bottom here, we can see that a sheep is a sheep of a bone. Again, weird, but I think the semantics follow. I think you can understand. So what we're doing there is we're creating two bidirectional relationships. Normally, a relationship is just, this is a something of that. But you can define the reverse as well, which is why we have more relationships in here than you might think we need. Because in some cases, you might want a one-directional relationship. And then we have the permissions. Let's follow permissions from the bottom to the top. Now, remember when I said that the graph can get big and complicated? Imagine trying to cache a 7-chain request. You'd have to cache that in its entirety, and then if somebody made a request between the first and the 6th entity, you'd have to recalculate the whole thing again. So what Permify does is it only chains up to 2, so that it can cache them more effectively, and then it can chain them together during recall time to make use of that cache. So that's the only reason why this looks a little bit strange when we look at how the permissions are defined. So when we define the permission to eat, we have sheep dot. So that sheep is a reference to, let's see if I can get this clicker to be still for me. Go on, there we go. So this sheep here is a reference to this sheep here. So we have a relationship between the bone and the sheep, and we want to allow the eat permission on this bone if the sheep's owner underscore dog, now owner underscore dog doesn't exist. Let's ignore that for now. Or sheep dot owner underscore friends underscore dog, which doesn't make sense either. Okay, let's propagate up. Let's have a look at sheep. So sheep has owner underscore dog and owner underscore friend underscore dog, which are these two down here that we saw in the bone. So basically deferring the permission lookup. So we're saying if the sheep would allow this to happen, if the sheep has this relationship, then allow eat. And then we can follow that up to friends underscore dog. And down here you can see that owner underscore dog is a direct relationship between owner and dog. So we're looking at the actual entities at that point. Owner friends underscore dog, again, this is almost like an alias to this. So essentially what we're defining here is if you're the sheep's owner, sheep's owner's friend, or the sheep's owner's friend's dog, then you have permission to eat. That's how that's been modeled in this. Remember I said that the policy documentation or the policy format is different from application to application. If you choose a different application, it'll look slightly different. But this is the general philosophy of how policy documents are defined. So, did I run that? I don't think I ran that. Let's copy this. And we can now see we've got a schema version come out. That basically means, yeah, cool, we've got a schema now. That version can be referred to, but I won't go into the intricacies of Permify schema. You can have multiple schema and you can refer to them, and it's quite powerful. So the next thing I'm going to do is create the relationships, and this is a set of tuples. So you can see here that I'm creating a relationship between the subject, Dolly the sheep, and the bone, and the relationship is of type sheep. And then we've got the reverse. The bone is related to sheep by type bone. So we've got the bone and the sheep, and then if I scroll down, we've got the sheep and the person, the farmer, and then the farmer and the sheep. So we're getting that reverse lookup, a reverse relationship. Then we've got the scientist and the dog shadow, and then we've got the dog and the scientist. So while I copy and paste this, can anybody see what I missed? I didn't create a relationship between the scientist and the farmer yet. We have the sheep and the bone and the farmer, the scientist and the dog. The sheep and the farmer, not the bone and the farmer. You know what I'm talking about. Okay, so we've now created these. If we scroll down a little further, we can now ask Permify, can you find anything where there's a bone called femur and there's a permission for dog shadow to eat it? So now we can start making requests on it. And if we put this in, we'll see at the bottom there, check result denied. Because I didn't create that relationship between the farmer and the scientist. Now, if you're doing this later at home, once you've cloned this repository, you can run it locally, and don't use the dictionary, that's not going to help anybody. Let's run that in here. And we'll come over here, and we'll go to localhost port 3000. All right. I hope you're really impressed with my design skills. As I say, I've been a software engineer for 25 years. I've not been a user interface designer for anywhere near that long. I have 33 seconds, but I promise you this is going to work. So what I'm going to do now is I'm going to grab the last piece of the puzzle, make friends. I'm going to create an extra tuple here. So this is the one that I didn't create before, between the farmer and the scientist. And if I come over here and we look at this, and I bring my terminal over here so that we can still see everything, and I paste this in, the door opens and the dog gets the bone. Last time I did that, it didn't work, so I'm glad it did. All right, so it leaves me only to put the final slide up with a couple of links for you to have a look at. There's the GitHub repository. There's the Postman collection if you want to use it. Thank you so much for your time. If you want to have a chat with me afterwards, I'm going to be hanging around outside. Thanks for coming. Have a great rest of your conference, and it's been a pleasure.